Hey everyone, welcome to Quick Bites of AI. I'm thrilled to have you tuning in today. We're diving into something that's surprisingly not as confusing as its name sounds. Yeah, the confusion matrix. I promise, by the end of this chat, the confusion part will only be in the matrix itself, not your mind. So, you might be thinking, what on earth is a confusion matrix? Well, it's basically a table used to describe the performance of a classification model. Imagine you've built a model that detects whether a fruit is an apple or a banana. The confusion matrix will help you see how often your model's predictions get it right or wrong. Now, let's dig into the components that make up this matrix. Picture a 2x2 table. On one side, you've got the actual labels, and on the other side, the predicted labels. The entries in the matrix are counts of the model's hits and misses. Oh, like counting how many times you failed to follow your own diet plan. We've got these legendary terms. True positive, TP, which is when your model correctly predicts something as positive. Like it says, yep, that's an apple, and it is indeed an apple. Then there's true negative, TN, where the model holds back its excitement. Like, no, that's not an apple, and it's right, it's not. False positive, FP, on the other hand, is like giving someone the wrong gift. Surprise, it's an apple, but wait, it's actually a banana. And false negative, FN, is when you missed out on congratulating the apple. It's like the unnoticed wallflower at a party. Okay, maybe it's easy to get lost in the apples and bananas. But here's why a confusion matrix is worth your attention. It helps you see not just how frequently your model gets things right, but also how and where it goes wrong. Kind of like realizing you've picked the wrong lines at the supermarket more often than you'd like. From this matrix, you can calculate a bunch of metrics that help in assessing the model. Accuracy is like your model's GPA. It's the ratio of correctly predicted observations to the total observations. Precision tells you how many of the positive identifications were actually correct. It's like checking if the diamonds in your jewelry box aren't just moissanites. Recall or sensitivity is all about catching all the positives. How good are you at tracking down every apple amongst all the apples and bananas? Oh, and F1 score. It's the harmonic mean of precision and recall, balancing them out like a seesaw for the perfect kid party, or maybe not, depending on your acrobatics. But why bother with all these metrics, you might ask? Well, understanding these can guide you in building a better model. Whether to keep it as is or to tweak your model parameters, just like finding the right temperature for your favorite coffee. We don't want it too hot or too cold, Goldilocks style just right. Thinking about practical uses. Confusion matrices are everywhere, from spam detection to medical diagnosis systems, where identifying the TP and FN could be critical in saving someone years of therapy. And no one wants to send Aunt Martha's emails to the spam folder, right? So next time you dive into some data or build a model, bring out the confusion matrix. It's like bringing an expert detective along who knows exactly where all the crimes are happening. All right, folks, that wraps up our trip through the confusion matrix. Not too bumpy, right? Keep this tool in mind as you explore more in machine learning. Thanks for hanging out with us today on Quick Bites of AI. Catch us next time as we dig deeper into more bite-sized mysteries of AI. Until then, keep crunching those numbers and don't let the data make a monkey out of you.